Good morning, students. This is Savita, Associate Professor in Mathematics. In this video, I shall explain Cramer's rule. This video is useful for 5th semester BSc students. Cramer's rule is one of the direct methods to solve linear simultaneous equations and is also called the method of determinants. So let us consider a system of linear equations in three variables. Say a1x plus b1y plus c1z is equal to d1, a2x plus b2y plus c2z is equal to d2, a3x plus b3y plus c3z is equal to d3. So we have three equations in three unknowns x, y, z. Okay. So in order to use Cramer's rule, we write the coefficient matrix first, that is a1, b1, c1, a2, b2, c2, a3, b3, c3. Write the determinant of the coefficient matrix and let us denote it by delta. Therefore, delta is equal to a1, b1, c1, a2, b2, c2, a3, b3, c3. That is determinant of these elements. If delta is not equal to 0, then we apply Cramer's rule. So first we write determinant of the coefficient matrix, evaluate the determinant. If it is not equal to 0, we shall apply Cramer's rule. Now what is Cramer's rule? How to find the unknowns? Now let us first find x. X is equal to 1 divided by delta into determinant of d1, b1, c1, d2, b2, c2, d3, b3, c3. So what do you observe from this? Now this is delta, correct? Here the first column elements are replaced by respectively d1, d2, d3. We evaluate the determinant and multiply it by 1 by delta. So x is equal to 1 by delta into determinant of, observe the first column elements are d1, d2, d3. Second and the third column elements remains the same. They are not changed. Okay. So evaluate the determinant, divide it by delta, that gives the value of x. Now let us find y. Y is equal to 1 by delta into determinant of a1, a2, a3, d1, d2, d3, c1, c2, c3. Observe the second column elements in delta. The second column elements in delta are replaced by d1, d2, d3 respectively. The first column and the last column elements are unchanged. They remain the same. Therefore, y is equal to a1, a2, a3. Determinant of a1, a2, a3, d1, d2, d3, c1, c2, c3 divided by delta. So evaluate the determinant and then divide it by delta, which gives a value of y. And z is equal to 1 divided by delta into determinant of a1, a2, a3, b1, b2, b3 and d1, d2, d3. That is, in delta, the third column elements are replaced by respectively d1, d2 and d3. The first and the second column elements remains the same. So evaluate the determinant, the new determinant and divide by delta, that gives the value of z. Therefore, if delta is not equal to 0, we find x, y and z using this method. So this is known as Cramer's rule, but this method fails if delta is equal to 0. So the above equations giving the values of x, y and z constitute the Cramer's rule, which reduces the solution of the linear system of simultaneous equation to a problem of evaluation of determinants. Also, this method is quite general but involve a lot of labor when the number of equations exceed 4. ಅಂದರೆ ಮ್ಯಾಟ್ರಿಕ್ಸ್ 4x4 ಇಂತ ಜಾಸ್ತಿ ಇದ್ರೆ, ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಫ್ ಆರ್ಡರ್ 4 ಇದ್ರೆ ಡಿಟರ್ಮಿನೆಂಟ್ ಇವ್ಯಾಲ್ಯೂಯೇಟ್ ಮಾಡ್ಬೋದು. ಅದಕ್ಕಿಂತ ದೊಡ್ಡ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಸಿಕ್ಕಿದ್ರೆ ಡಿಟರ್ಮಿನೆಂಟ್ ಇವ್ಯಾಲ್ಯೂಯೇಟ್ ಮಾಡಲಿಕ್ಕೆ ತುಂಬ ಕಷ್ಟ ಆಗ್ತದೆ. ಆ ಸಂದರ್ಭದಲ್ಲಿ ನಾವು ಕ್ರೇಮರ್ಸ್ ರೂಲ್ ಹೊರತುಪಡಿಸಿ ಬೇರೆ ಯಾವುದಾದ್ರೂ ಡೈರೆಕ್ಟ್ ಮೆಥಡ್ ಅಥವಾ ಇಟ್ರೇಟಿವ್ ಮೆಥಡ್ಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿ ಸೊಲ್ಯೂಷನ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಲಿಕ್ಕೆ ಆಗ್ತದೆ. ಸೊ ಕ್ರೇಮರ್ಸ್ ಮೆಥಡ್ ಫೇಲ್ಸ್ when delta is equal to 0. Okay. So using this Cramer's rule, let us solve one problem. Problem is, apply Cramer's rule to solve the equations 3x plus y plus 2z is equal to 3, 2x minus 3y minus z equal to minus 3, x plus 2y plus z equal to 4. Now here there are three variables, three variables or unknowns x, y and z. We write the coefficient matrix first, which is equal to matrix 3, 1, 2, 2 minus 3 minus 1, 1, 2 and 1. Then write the determinant of the coefficient matrix, which is equal to determinant 3, 1, 2, 2 minus 3 minus 1, 1, 2, 1. Evaluate this determinant. Evaluation of determinant gottide namage. So let us evaluate 3 into minus 3 plus 2 minus 1 into 2 plus 1 plus 2 into 4 plus 3. Simplify madi. Delta is equal to 8. Then use the formula x is equal to 1 divided by delta into determinant of. ಈ ಡೆಲ್ಟಾದಲ್ಲಿ ಫಸ್ಟ್ ಕಾಲಮ್ elements are replaced by 3, minus 3 and 4 respectively. So x is equal to 1 by 8 into determinant 3, 1, 2, minus 3, minus 3, minus 1, 4, 2, 1. Observe, second column and third column elements remains the same. Evaluate this determinant, that is 3 into minus 3 plus 2, minus 1 into minus 3 plus 4, 2 into minus 6 plus 12, which is equal to 8. 8 divided by 8 is equal to 1. Therefore, x is equal to 1. Next, find y. In delta, the second column elements are respectively replaced by 3, minus 3 and 4. Therefore, y is equal to 1 divided by 8 into determinant 3, 3, 2, 2 minus 3 minus 1, 1, 4, 1, which is equal to 1 by 8 into 16, that is equal to 2. Evaluate this determinant, it is equal to 16. 16 divided by 8 is equal to 2. Z is equal to 1 divided by 8 into determinant of delta dalli third column elements are respectively replaced by 3, minus 3 and 4. So we have the determinant 3, 2, 1, 1 minus 3, 2 and 3 minus 3, 4. Evaluate this, which is equal to 3 into minus 12 plus 6 minus 1 into 8 plus 3, 3 into 4 plus 3, that is equal to minus 8. So z is equal to minus 8 divided by 8 is equal to minus 1. Therefore solution is x is equal to 1, y is equal to 2 and z is equal to minus 1. ಈ ಸೊಲ್ಯೂಷನ್ ಸರಿಯಾ ತಪ್ಪಾ ಅಂತ ನೀವು ಪುನಃ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ವೆರಿಫೈ ಮಾಡ್ಬೋದು. x is equal to 1 ಹಾಕಿ 3 into 1, 3 plus y, y is 2. So 3 plus 2, 5. Z equal to minus 1. 5 minus 2 is equal to 3. So x is equal to 1, y is equal to 2 and z is equal to minus 1 is the solution of this system of linear equations. System of linear simultaneous equations. Okay. So I hope you have understood Cramer's rule. So this is one of the direct method for finding the solution of simultaneous equations. Reference book is Dr. B.S. Grewal, Numerical Methods in Engineering and Science with Programs in C and C++. I shall stop here. Thank you.